Okay, great. So we are live now. Okay, so before sharing the PRD code and all, anyone can you tell me what do you mean by the central limit theorem? What is the key idea behind the central limit theorem? What do you understand by the central limit theorem? Anything there. Do not worry about right, wrong. Whatever the things you have understood till now, just can you tell us?
So the sum of IID random variables,
Hmm.
let let it be y. If we divide it by root 10, and this random variable y by root 10 can be approximated as normal 0 1. I mean
Okay.
normal sigma square. This is
Okay.
the basic idea of central limit theorem, I guess.
Okay. Anybody else? Correct. That's correct. Any other thoughts? What we are doing in central limit theorem basically? What is the work going on?
So basically, simplify the calculations.
Okay. For large size.
Yes.
Okay.
So
So can,
basically,
hmm. Go ahead. Go ahead. Go ahead. Go ahead, please.
in the central limit theorem, we find the mean of the large population or very large number of samples,
Hmm.
which is nearly about the population mean. We can say.
Nearly about the population mean. That's also correct. Okay. So let me share my screen. Anybody else would like to say something? Yes. No.
So the MGF of the other distributions are can be approximated as normal distribution. That is the thing in CLT, I guess.
Okay. Correct. Okay, so what we are doing in central limit theorem. So in the key idea of central limit theorem is nothing but approximating the probabilities. Okay. First of all, I would say so we are approximating the probabilities. Would you agree with me, all of you?
Yes, sir.
Correct. Now, what's the key idea? I will tell you. So the thing is, let me write the definition, then I will come back to slides of the question. I just wanted to give you the recap of central limit theorem. So let's say I'm saying x1, let's say x2 till xn. Okay, these are, let's say, IID. I am hoping everyone is aware about what is the IID, right? IDX with,
Yes.
let's say, expected value of x is 0 and variance of x is sigma square. Okay. The thing is, if I will say, let's say I'm defining a random variable y, which is nothing but x1 plus x2 plus so on plus xn divided by root n, then in that case, okay, so this mgf of y, okay, it will converge to, it will be basically e raised power lambda square sigma square divided by 2. And what is this? This is nothing but mgf of normal distribution, normal 0
Yes, sir.
comma sigma square, correct? So this actually what we are saying here, what do we mean by say? So here you will say y is said to be converge in distribution. Okay, converge in distribution to normal 0 comma sigma square. So we are not going to the depth. That's not important as of now. So there are two to three kinds of convergence. So converging probability, converging distribution, something like that. So that's not a part of our syllabus. I'm just giving you idea. So this is true when your n is large, right? Would you agree with me? Okay. So what is the reason behind this? I mean, how it is working? Okay, let's try to see. Okay, I will take something. So this is not necessary. It will you to always divide by square root of n. Okay. So let me show you something. So suppose what I'm going to show. So let's say using central limit theorem to approximating the probabilities. Okay, that's what I'm saying. How we are doing, I will explain you. Okay. So let's say I'm saying again the same x1, x2 up to till xn. Okay, this is IID which follows x. Anyone, what is the IID?
independent identically distributed.
That is the full form. What do you mean by why we are taking the IID sample?
Basically, in this we can say that all the samples are identical and they are independent, which means the
Following the
probability.
same distribution.
That,
Distribution is same.
that's correct. My question is why? Why we are
Because is it
more
easier to
Because it
calculate?
is easier to
inclined
calculate,
to the IID samples, not any other.
easier to approximate the probability for these random variables, IID random variables.
Okay. Okay. Let
If
let
it
me let
wasn't
me give you.
IID, then there would be much complicated calculations, I guess.
Okay. So IID means okay. So full form of IID is okay, right? It's identically and I mean independently and identically distributed. Correct?
Yes, sir.
Right? So okay, let me give you the idea of the IID. Then I will move on. Okay. So so IID is nothing for it's independently and identically distributed. So identically means can I say there are no overall trend? I mean basically we can say the distribution doesn't fluctuate, right? And
Correct.
we can say all the items in the sample are taken from the same probability distribution. That is the meaning of identical, right? Independent means sample, I mean, they are not connected to each other in any way. Okay. What do you mean by not connected to each other? Basically, that means if you have the knowledge of the value of one variable, that shouldn't give the information about the second variable and vice versa. Yes or no?
Yes, sir.
So why it's important? Suppose you want to see, I mean, your objective is to check the basically duration of length, something length. Uh, yeah, you want to check the amount of time, duration of time, the leaf of a particular plant. Let's say leaf of a rose plant. How much time it is taking? Something like that. Any objective you have. So suppose you have collected the two kind of sample. Let's say sample one you have collected. Let's say you collected with the same characteristics from the lotus plant, and let's say some lily plant and some rose plant and some other. Okay, let's say other plant. I mean the same for the to test your objective of the study you have collected these samples, okay, for to check the same objective. Now the second sample you have collected the rose plant one. I mean there is one rose plant, and there is another rose plant which is independent. There is no dependency somehow, and third rose plant and some fourth rose plant. Okay, so which sample will give you the better result?
Sample 2.
Sample 2, right?
Yeah.
Okay, so you can see this all are independent and all are identical also in the second sample. Okay, so that's the key idea behind this IID. Okay, let's move here our part. Okay, suppose I'm saying I'm defining y as a x1 plus x2 plus so on xn. Okay, suppose n is larger. Okay, I'm just assuming. Then how will you go for this? Okay, how will you approach for this? So then what will be the key thing is central limit theorem. If you have any question related to central limit theorem, right? What you have to do, just convert that random variable into standard form, right? Standardized form. Are you getting my point? So if I want to convert this in the standard form, so what will be the case? Let's say then I have to do y minus expected value of y divided by standard deviation of y, right? That is the standardized form.
Yes.
Okay.
Yes, sir.
Now, if I'm writing, suppose I'm writing y minus n mu divided by square root of n, then what it will follow? Can you tell me the distribution?
Normal
Normal
0.
0 sigma square.
Normal 0, comma
Sigma
sigma
square.
square. Okay, let me write why this is true. So if I will write expected value of y, then it will be expected value of each exercise.
Yes, sir.
Correct? And it will be mu plus up to n times. So this will give you n mu. That's what we have done. If I will write variance of y, then since all are IID, then I can write variance of x1 plus variance of x2 plus so on till variance of x of n. Correct? This will be n times of sigma square. So here you can see in the numerator, denominator part, this, okay, what will be the standard deviation of y? Square root of n sigma. All right. So you can see clearly, I didn't use the sigma part here. Then variance, this will be sigma square, yes or no?
Correct.
Correct. And if I'm writing like this, y minus n mu divided by square root of n into sigma, this will be normal 0, 1. Would you agree with me or not?
Yes, sir. Standard normal.
Standard normal, right? Because I subtracted the mean and divided by the standard deviation of y. Is this clear to all of you?
Yes, sir.
Right. Now, the next thing is, suppose I'm saying if y is x bar, okay, this is not summation of xi. So y can be defined anything, right? It's x bar, summation of xi, anything it can be, right? Suppose I'm saying y is equal to x bar is nothing but x1 plus x2 plus so on xn divided by n. Okay. Now what we have to do, let's try to find the expected value of y first. So if you will calculate the expected value of y, then can I write 1 by n outside? Then I can write expectation of x1 plus expectation of, I'm skipping the step here. Everyone is getting this part?
Yes, sir.
So numerator part will be mu plus mu plus mu up to n times. This will be n mu divided by n. N will get cancelled out. So what is this? Expected value of y is mu. Yes or no?
Yes,
Excuse me, sir.
Yeah, go ahead, please.
Sir, please explain once again this part. Expectation of y.
So what is the expectation of x1? It's a mu, right? It's given in the right. So it will be mu plus mu plus mu up to n times. So it will be n mu.
Okay.
Okay.
Yes,
Now,
sir.
if you come to the variance of y, then can I write variance of 1
Sir, I am
upon?
unable to understand the 1 by n.
It's a given x bar.
Okay, okay, ठीक है. Okay, sir.
So this.
Excuse me, sir. One more
Huh?
doubt. The doubt which I have got is the above one, sir. Why we are taking the distribution of n 0,1? This one.
This is the key part of central limit theorem, right? We have to, if you see, n is large, then this part will follow the normal distribution with mean 0 and variance 1. All right. So if you see, the thing is, what we have to do, whenever you have question related to central limit theorem, just you have to convert in standard form, right? So it will be normal 0, 1. That's all. So you can see I have subtracted the mean, and mean is n times mu, and I have divided by the standard deviation, and standard deviation is square root of n times square root of n into sigma. Correct?
Yes. Thank you.
Okay. So central limit theorem, under central limit theorem, it will be normal distribution. I will show you something, right? Just give me 2 minutes. Okay. So what is this part? Variance of any constant into x. This is a square into variance of x. Would you agree with me?
Yes,
So
sir.
can I write 1 upon n square? Then variance of summation of each xi is here, right? Since all are
Yes, sir.
independent, so can I write like this? Variance of x1 plus variance of x2 plus so on plus variance of x of n. So this will be sigma square plus so on, sigma square divided by n square. So this will be n times of sigma square divided by n square. 1 n will get cancelled out. So here you can see variance of y is sigma square by n, and expected value of y we got mu. Yes or no?
Yes,
So
sir.
if you see, if what will be the y minus expectation of y divided by standard deviation of y, can I say y minus mu divided by sigma by root n will follow normal 0, 1 as per the central limit theorem or not?
Yes, sir.
Right? At the same point, if I'm writing y minus mu divided by 1 by root n, then this will be normal 0,
Sigma square.
sigma square, right? Is this okay? So you can see y is any kind of linear function of your random variables, okay? Random variables of x1, x2, xn, basically with some mean mu and standard deviation of y. Then what we have to do, with this help of central limit theorem, what then it will be y minus expected value of y divided by standard deviation of y will follow normal 0, 1. Basically, you can see the sample mean is converged to the population mean also, right? That's the key thing. Whenever sample size is large, it will follow the normal distribution. Okay, so far so good.
Sir, last part I'm not getting. Where you have written y minus mu divided by 1 upon root n is following.
Okay, one more thing. Just treat at this as a w. Can you find the expectation of w and variance of w?
Expectation as per represented, it will be mu.
Expectation, how it will be mu? Expectation of w means expectation of y minus mu, right?
Okay.
1 upon root n. Expectation of y is mu minus mu. This is 0.
Yes.
So variance of w, so 1 upon square root of n, this will nothing but, if you see, so variance of y minus mu divided by 1 by root n, right? Basically, I'm saying variance of square root of n y minus mu. That's what, right? So this square root n is what? This is n, right? Variance of y minus mu. So this is n. Variance of y, what is this?
N sigma. Okay, sir.
Excuse me, I had a doubt. My doubt is it's a bit more technical. Like it's not directly related to statistics too, but it's about the z-scores. So sometimes in questions we'll be required to find the z-score, right? So how do we find that using the calculator of IITM? I'm not sure about
that. That will be given to you in a question paper. Okay.
In one of the previous year question papers, the z-score wasn't given.
No, then it's something that's very obvious. Very obvious means if something like this, if you have probability z greater than 0 or probability z less than 0, what it will be?
0.5.
That is something very obvious, right? If there is anything, let's say probability greater than 1 minus 1.33, for this kind of things, values will be given to you. Okay.
Okay, so we don't need to. We don't need to use the calculator.
Nothing. So you cannot find the z-score from the calculator actually.
Okay, so another thing is, how many weeks of class do we have for the course? Do we have a class for the whole 12 weeks, or will there be content only till the 9th or 10th week?
No, it's a 12-week course.
Okay, thank you.
Okay, yeah. I think, is this correct?
So in the W part, the denominator we should write sigma by root n, right, sir? As standard deviation as to
correct. That's what I'm saying, thinking. So variance of y is nothing but sigma square divided by n, right? So this will be sigma square only, correct?
Yes.
Okay. So you can see now this is sigma square. Okay, so I have done some animation with the help of R software. I don't know how many of you are aware about this. This is not the part of course at all. The thing is, I want to show you the central limit theorem part. Okay, central limit. If you see here, can you see this animation part? If you see now sample size is 5, right? Whenever sample size is large, it is going to converge to the population mean. Population mean is 1. If you see sample size is 20, now 30. That's a 450, right? You can see now it's converging to the normal distribution, right? 100, right? 200. So till 200, so this sample mean is like converge to the close to the population mean. Yes or no? Are you getting?
Yes, sir.
So you can see if n is large, the thing will converge to the normal distribution basically. Okay? Is this correct? All right. So I have something different also. You can see now it's just not a slow animation. It's a bit fast. Okay. Is this clear, right? Idea is okay or not? Are you can see, right? Sample size whenever it is increasing, you can see it is converging to the normal distribution curve, right? Or else you can see the sample mean, x-axis sample mean. You can see population mean is 1, and when sample size is increasing, it is converging to the population mean. Okay. All right. Sir. Okay. So now the usual task, please join this peer deck slide and we will try to solve the questions. Okay. So what you have to do, open your browser, either in your phone or desktop, laptop, whatever you have. Just write down, just enter this, just write joinpt.com, and after that it will ask to enter a code. So code is KSSHUK. Okay, so I would
Sir,
request to all of you, please join it fast so that we can start the solving the questions. Okay.
sir, one small note, sir.
Huh.
In the formula you boxed for central limit theorem, that
Huh.
y follows 0 to 1 for normal. Is
Huh.
y is a linear combination of x, or y is only the sum of the IID random variables? Which is the case we follow, sir? Is
Some
it
of the so it can, you see, y can be summation of xi's, y can be x1 plus x2 plus xn divided by square root of n, x1 plus x2 plus xn divided by n. Okay, anything it can be. The thing is, you have to keep in your mind, you if you do y minus expected value of y divided by standard deviation of y, right, of any form, it will be the normal distribution. It will converge to the, it will follow normal 0 comma 1 as per the central limit theorem. The condition is n should be the large.
Sir,
Hmm.
so one small thing. So
Hmm.
like in this in the like when we apply the CLT, so
Hmm.
like we have the formula, not formula, like we write like why we when we write to solve, when we use y minus n mu by sigma into root n, right, sir?
Mm-hmm. Mm-hmm.
But sir, like just wanted to ask you, when we were just you were just showing the last calculation,
Hmm.
in one part like we have y minus mu by sigma by root n.
Hmm.
So that basically formula, it gets converted to y minus n mu by sigma by
No,
root.
no, no, no. It's not that. Uh-huh. So you didn't get the idea. So I think, say, if you see here, what is the y? Y is just a x1 plus x2 plus xn divided by n.
Correct.
Not divided by x1 plus x2 plus till xn, right? If
Uh-huh.
you'll calculate the expected value of y, the key thing what you have to remember in your mind, just see n is large, and as per the y is defined, just find the expected value of y and standard deviation of y, and divide, subtract the expected value of y, standard deviation of y. It will follow normal 0 comma 1. So if you calculate the expectation of y, so this will be n mu.
Correct.
What is the variance of y? N sigma square.
And sigma square,
What
correct.
will be standard deviation?
Root n sigma. Okay,
Then
got it. Got it. Got it.
understood. Now if you see in this case, y is x bar, not x1 plus x2.
It's okay, sir. I got it. I confused myself. Yeah, no
Okay, oh,
problem.
no problem. So I would request to everyone, please join it fast so that we can start session. It's already 30 minutes about. Okay. So I'm assuming everyone knows how to join this. Is there anyone who is facing any difficulty? Please do let me know. I will explain. By that time, let me repeat the process. What you have to do, open your browser, you have to enter this joinpd.com, just write joinpd.com, and it will ask to enter a code. Code is KSSHUK. Okay. Once you will enter the code, you will be able to see the slides, whatever I'm going to present on my screen, as well as you can enter the answers. Basically, you can input the answers from your end. Okay. And that will be, okay. So okay, so I will wait for 2 more minutes, then I will start this. Okay, so I would request, there are around 50 people in the class. So half of you have joined. I'm requesting to others, please join it fast. So it is going to help you to understand the problem related to central limit theorem, and it will give you the idea to solve the questions in your quizzes. Okay, so it's better to solve with us. Okay. Okay, so you can find the YouTube link on the calendar also from the playlist also. Okay, so I'm going to start the questioning part. So others please join it fast. Okay. So it will help you. So the thing is, what you will do, just enter your, just open your browser either in your phone or desktop or laptop, whatever you have, and enter joinpd.com. After that, it will ask to enter a code. So code you can see on my top right side corner on my screen, which is KSSHUK. Okay. So please join it. It is going to help you to understand the different kind of problem related to central limit theorem, and which will help you to understand the problem in, I mean, to solve the problem in your quizzes. Okay. So very first question is, let x1 x2 xn till x100. So in statistics, in some books they are referring sample size more than 30 as a large sample size. Okay, it depends, but mostly it's n is greater than 30. Okay, it can vary also, but most of the books follows this, and if n is greater than 30, they consider as a large sample size. So let x1 x2 x100 be independent, identically distributed random variables, each with expected value 3, and variance is given to as a 9. Question is, you to approximate the probability x1 plus x2 plus x100 greater than 100 using the central limit theorem. So you have to write your answer in abject terms. Okay, there is no abject values is given to you. It is asking you to write the, it will be abject of something. You to write the answer. So I'm going to give you 3 minutes. Please do let me know if you need extra time limit for this. Okay, feel free to ask.
So we need to enter the inside value also.
Correct, correct. So you have to enter the answer, and submission will be automatically.
Okay, sir.
Okay, so anyone, do you need extra time limit?
Done, sir.
I have received only 13 responses. What about others? Are you trying? So feel free to ask for time, right? So by the What's the key idea behind this? You will get the idea whether you are able to do this kind of question in 3 minutes or 5 minutes or something, right? So should I extend the time limit?
Yes, sir, we are trying.
1 minute or 3 minutes you need?
So 1 minute.
Oh, okay, great. Yeah. Okay, anyone? Do you need extra time limit? Please feel free to ask. Yes, no?
Done, sir.
So I just wanted to know why others people are not trying. I mean, you don't want to try, or what is the reason?
Sir, 30 seconds more.
Okay, so it's just for to all of you, right? So please try to solve the question. This is not any graded or something. Okay. The thing is, you will get idea. You will get some confidence that you are able to do the questions within the given time limit or something like that, right? You will get some idea. Okay, so that's for you. If you are not attempting, then you cannot do something, right? So it's up to you. The only thing we can request to all of you to attempt the questions. Okay. Otherwise, we can share the PDFs before the. I mean, we can upload the PDF on the portal, and you can do on your own. That's also one thing. Okay. Anyway, so let me do my
I
job.
think it's a favorite dialogue, sir.
It's not about favorite. It's just all about the thing you are not doing from your side. That's not about the thing.
I
Sir, I
have
am not
submit
able
the
to do that.
answer.
Okay.
Sir, I am not able to do. I don't know how to proceed. Like I know the formula, but
Mhm.
application.
Anyway, that's fine. So that's fine, right? That is something at least you are honest. Okay, honest about the things. It's not okay. Anyway, so let's try to see. So what we have discussed. So here, what will be my y? If you see, then y is nothing but I can say x1 plus x2 plus so on till x100, right? And we have to calculate the approximate the probability y is greater than 100. Correct? What
Yes,
is
sir.
the task and what is the mean of each xi? So 3 and variance is 9. So mu, that is expected value of each xi is 3, and sigma square, that is variance of each xi is 9. Then what we have to do, as we have discussed, we have to convert this y into standard normal form, right? So what will be the expected value of y? First of all, it will be expected value of x1 plus x2 plus so on x100, correct? And this will be 3
Three,
plus
300.
3 plus 3 so on till 100 times. Basically this will be 100 into 3, that is 300.
Yes, sir.
Right? That's very simple thing. Now, what is the variance of y? So it will be variance of x1 plus x2 plus so on plus x100. Correct? Now this will be variance of x1. Since all are IID, I can write like this. Correct? So I mean this is something I can write because of independency, right? So this will be 9 plus so on 9. So this will be 100 times 9, which is 900. So far so good.
Yes, sir.
So as per the central limit theorem, what will be, can I say y minus expectation of y divided by standard deviation of y, that is y minus 300 okay, divide by square root of 900 will follow normal 0 comma 1 or not?
Correct.
Yes,
Correct?
sir.
This is the central limit theorem. So what we have to calculate? So probability that y is greater than 100. Yes or no? So this
Yes,
will
sir.
be probability if I will do y minus 300 divide by square root of 900. This is greater than same task I have to do 300. One second. 100 minus
100
300, right?
minus.
So 100 minus 300 and divide by square root of 900. Can I do or not?
Yes, sir.
Right? I have done for both sides. So this will be this which I have highlighted in the red circle. This will be, can I write as a G? Because this is
Yes, sir.
standard normal variable, and this will be minus 200 divided by 30.
Sir, one small thing.
Hmm.
Sir, I don't know if I'm. Sir, in this one, we have to take, in the denominator, we only have to take the standard deviation y, right? Not the root
Yes.
and sigma.
Okay.
Oh,
What
it's
is
the
Perfect.
same, no?
same thing, right? Okay. If you'll do under root and sigma,
No,
what
it's
is
the
the
same
under
thing.
root and?
Correct, correct.
This
Sorry,
is
sorry.
10, right? And sigma will be 30, right?
Correct, correct, correct. My bad, my bad, my bad.
Okay. So now you are getting 30 only, right?
Sir, can
So
you explain the thing like 100 minus 300? Why we have done that?
see, if I want to convert this in standard normal form, okay, I have to subtract the expected value, which is 300.
Yes, sir.
If you this is the standard normal form, right? So I have
Yeah,
to
sir. I
subtract the
got it.
mean. Then this will be, I have to subtract the mean from both sides, right? You cannot perform anything only one side, right? One side of the equation. You have to do on both sides, yes or no?
Yes, sir. Yeah, now
Now,
I got.
got it? The same thing we have done, right? So now
Yeah.
if you see, to convert in FZ form, I have to write as a 1 minus probability Z less or equal to minus 20 by 3. Would you agree with me? Can I write this one or not?
Yes, yes.
Right? And this is nothing but 1 minus FZ of minus 20 divided by 3. So sometimes this value will be given to you, whatever the value of minus 20 divided by 3, FZ of this value will be given to you in your exam if needed. Otherwise, you have to solve this. I mean, it will be clearly mentioned how to you have to proceed. Okay? So this will
Sir,
be the answer. Hmm.
could you please explain that why we have written that in the form of Z, like the above one?
So what is
Yes, sir.
this? This is standard normal form, right?
Yes, sir.
That's what we are converting, right? So what is the, you are usually we are writing G as a x minus expected value of x divided by standard deviation of x, right?
Yes, sir. Okay.
Okay, understood?
Yeah,
Sir,
sir. Thank
I have a doubt, sir.
Hmm.
Sir, question is, you have written that n in bracket 0, comma 1.
Hmm.
So what is this 0, comma 1 and n?
Okay, so is this your first session throughout the term?
Sir, actually, I was not attending the class for a long time because I was preparing for JE, sir. That's why.
Okay, no problem. So what is this? If I'm
Yes,
writing
sir.
normal mu comma sigma square, what do you mean by this? How will you interpret?
So this is no, sir. Sorry, sir. My answer.
Okay, then for this, I will give you idea. That's not a problem at all. I will take 1 minute. So, but have you idea about any kind of distribution? But I would request you to go in the stats one and watch some lectures. Okay, of the stats one course. So, if have you idea about distribution, any kind of distribution, binomial, Poisson,
Yes, sir.
or exponential, or have you heard about this kind of distribution or not?
Yes, sir.
Okay, so there is similar kind of something. There is another kind of, suppose I'm saying x following normal distribution. Okay, so parameters for this normal distribution are mu comma sigma square. Okay, so this mu is nothing but this is the expected value of your random
And
variable.
sigma square is variance.
Okay, now you got it.
Yes, sir.
So this 0 is the mean and 1 is the variance. Okay.
Okay, sir. Thank you, sir.
So you can see the 1 minus subject of minus 20 divided by 3. This is the value. So here in the solution it has been taken as 100. That's not a problem. You can define anything. I took just for simplicity y. Okay. So the next question is x1, x2, x100 are IID normal 0, comma 2. You have to evaluate the part probability x1 square plus x2 square plus so on x100 square greater than 220 approximately using the central limit theorem. Okay, can you tell me if you have x1, x2, x100, then what will be the form of what will be the distribution of x1 square plus x2 square plus x100 square?
Gamma
Gamma.
distribution.
Gamma distribution.
Gamma.
So use that concept and then your y will be gamma distribution, right? With some parameters. Okay.
Yes, sir.
Okay. Then use that concept and apply this part. And here you can see abjad value is given to you and you can use this value. Okay. So I'm going to give you 3 minutes. Do let me know if you need extra time. So I would request to everyone, please try to attempt the question.
Sir, how can you tell that it is a gamma distribution? Like it's following gamma distribution.
Okay, so that is the property you have to keep in your mind. Okay. So if x is following normal 0, comma 1, okay, standard normal 0, comma 1, let's say there is any x, then x square. Okay, can you tell me what will be the x square? X square is nothing but the, then
Half
it's a
into
pi square.
comma half sigma square parameter.
No, no, I'm saying if I'm talking just about x only. If x is normal 0, comma 1, then what will be the distribution of x square? This is chi square. Yes or no? So you can see the last lecture. Okay, so last lecture sir has discussed these things, different kind of distributions. But let me give you this. So there is property if x1, x2, xn are IID. Let me write the thing.
Yeah, sir, I have seen it right now. Yeah.
Okay, so if x1, x2, you have to think now x1. This is all are IID with normal with mean 0 and variance. Let's say sigma square. Then xi square will follow each xi gamma 1 by 2 comma 1 by 2 sigma square, and this all will be independent, right? And sum of these all IID, let's say x1 square plus x2 square plus so on plus xn square, this will follow gamma distribution with parameter n by 2 comma 1 by 2 sigma square. So we are not going into the derivation behind it. You can keep in mind right now, just relate with the parameters. Okay, so I'm okay. So anyone, do you need extra time limit? Should I increase again time limit till 3 minutes?
Yes,
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 sir.
sir. Yes.
Oh,
No
oh. Okay, anyone? Do you need extra time limit?
1 minute, sir.
Okay, okay, all right.
So not able to get in this question.
So 1 more minute, sir, please.
Okay, okay, no problem. Okay, so Poonam, you haven't joined this peer day? So if you, because you are sending the answer on chat box, so I would request to join this peer deck slide. What you have to do, just open your browser.
Sir,
Huh, huh, huh.
sir, I want to edit the response in the peer deck, but I'm unable to edit it because I have print some wrong number.
Okay, no problem.
Sir,
It's
actually I am
point two
unable
three
to.
eight eight five.
Okay, all right, no problem. We'll see, we'll see. We'll try to solve and we'll see what is the answer. Okay. Okay, let me see the responses from your end. Okay, 0.543, 0.3885, okay, 0.238 is majority. Okay, let's see. There are other answers also. Okay, so as per the things which we wrote, so if x1, x2, xn are id normal 0 comma sigma square, then x1 square plus x2 square plus up to xn square will be gamma n comma n by 2 comma 1 by 2 sigma square, right? So here what is the case? X1, x2, x100, right? This is IID normal 0 comma 2. This is the question. Yes or no? So as per the concept, what it will be? So distribution of this will be gamma. So n is 100. So it will be 100 by 2. Yes or no? And 1 upon 2 into sigma square. So sigma square is 2. So this will be gamma distribution 50 comma 1 by 4. Would you agree with me or not?
Yes.
Yes.
Yes, sir.
Right. Now the thing is we have to calculate the mean and variance basically, right?
Yes, sir.
So what is the mean of gamma distribution?
Alpha by
Also,
beta.
Alpha by beta, right? So this, let's say this is y. Okay. Then what will be the expected value of y? This is okay. So if you see, if any random variable follows gamma distribution with parameter alpha comma beta, then mean is alpha by beta and variance is alpha by beta
square.
square. So mean will be 50 divided by 1 by 4, which is 200,
Yes, sir.
and variance of y will be 50 divided by 1 upon 60, which is 800.
Yes, sir.
Is this correct? 800, right? Yeah. Okay.
Correct, sir.
Now, if you see what we have to do, what is our task then? What is the next? What should be the next step? We have to calculate this probability x1 square plus x2 square plus so on plus x100 square greater than 220. This is something I can write probability y greater than 220 because we have defined y as a this part, right? What is the next step? So my next step is I have to convert this into the standard normal form, right? For this, what we have to do? Y minus expected value of y divided by standard deviation of y, right? The
Correct.
same thing Okay, let's try to do like this. So expect y. So can I we have to do on right hand side also? If I will divide standard deviation of y, I have to divide by standard deviation of y on right hand side also. Yes or no? So
Correct.
this will be
Yes.
anyway. This is going to be z, right? This will be z, right? Yes or no?
Yes.
And this will be 220 minus what is the expected value of y? 200. What is
100.
the standard deviation of y? So standard deviation of
Root
y would be square root of 800, which is nothing but uh,
20.
20 square root of 2, right? Can I write 20 square root of 2? Everyone are getting my point? So this will be probability z greater than, so 220 minus 200, this is minus 20 divided by 20 square, 20 into square root of 2. 20 will get cancelled out, so this will be probability z greater than minus 1 by square root of 2.
So it
Uh,
will be 20, no? Positive.
oh, sorry,
Will
sorry.
be
Correct,
positive.
correct, correct. Yeah, yeah. Sorry about that. Okay. So this will be to convert in abject form. I would write probability z less or equal to 1 minus probability z less or equal to 1 upon square root of 2. Okay. So this is something I can write 1 minus fz of 1 divided by square root of 2 or not.
Yes, sir.
So this is
Yes, sir.
1 minus fz of 1 square root of
0.707.
0.70
707.
and value is given to us, right? Which is 1 minus something, what is the value? 0.76115. So if you will solve this, let me calculate. 1 minus 0.76115, this will be 0.23885. This is the answer. Everyone is getting the idea?
Yes, sir.
Okay. So correct. So 0.23885 is the correct answer. So you can see, yeah, so this is the correct answer. Let's move to the next part. Here you can see x is the random variable having the gamma distribution, and there are two parameters. Alpha is n and beta is 1. Okay. Hint is given to you, mean and variance. You have to use the vehicle of large number to, you have to find the value of n such that probability that modulus of absolute mod of x by n minus 1 is greater than 0.01. This is less than 0.01. Okay. So what is the vehicle of large number?
Probability of x bar minus mu modulus of x bar minus mu greater than delta is
Hmm.
less than or equal to sigma square by n delta square.
Sigma square by n delta square. Okay. So what you have to do? Can you think about n? What will be the n here? Can you convert n in something, some part or something like this? Okay, let me write the vehicle of large number. So I'm just writing WLLN, vehicle of large number. Okay, so x1, x2. Okay, this is still xn. This is IID x. Okay, and expectation of each xi is mu. So expectation of x will be basically mu. Okay, and sigma square is the variance of x. So suppose I have defined sample mean as x1 plus x2 plus so on, xn divided by n. So what weak law of large number says? So what will the expectation of x bar here? Mu, and variance
Mu.
of x bar sigma square by n.
And
Okay. So then probability that absolute difference between x bar minus mu greater than some delta less or equal to sigma square divided by n delta square. So basically this will converge to 0 as n tending to infinity. Basically n will when n is your large. So you can think of something here. So what is your x bar? X bar is nothing but x1 plus x2 plus xn divided by n. All right. So you can think something like this here. Okay. So you can just relate this part with the here. So here x, can you think x is something each xi?
yes.
Can you convert? Why I'm saying like this? Because if you see what will be the each xi, if you see the above formula, okay, let's just try on your own. Let me give you the hint. So here you can, in this particular question, you can define your x as a x1 plus x2 plus so on xn, and this is following gamma n comma 1, right? This is the case you have to given. No, no. Yes, yes, right? Accordingly, you have to think now, okay? Yes or no? Are you getting my point? So, what will be the distribution of each xi here? 1 comma 1. Yes or no? Because if you see here, what is this? Summation of n gamma. Gamma. It will be n times, right?
Yes, sir.
Variance is going to be same, right? So just think 1 comma 1 n comma. Okay, anyway, let's just try on your own. I will discuss this.
Sir, this alpha equal to n and beta equal to 1. This is for the
Correct,
sum of
correct.
random variables or just for each variable?
No. So how I have defined x? I have defined x as a sum of random variables, right? This
Okay,
whole
okay.
thing is
Yes, sir.
following gamma n comma 1. Okay.
Yes, sir.
Hello, sir. Excuse me, sir.
Yes. Yeah. Tell me.
Yeah, I'm unable to edit my answer in PDEC, peer deck.
You can submit only one time.
Okay.
Hmm.
Okay. Yeah, I think answer is 10 lakh.
Whatever the answer, I don't know, but let's see. Okay.
Okay.
Sir, 1 minute more.
Okay. Okay. No problem. I will extend.
Sir, my answer is coming something 10,000.
Yeah. So I don't know the answer. I will solve and we'll see. Okay. So whatever the answer you are getting, just input from your side. Okay.
Sir, I have already typed the answer.
Okay. No problem. So I have extended the time limit. Please do let me know if anybody else need extra time limit. Okay.
Sir, little more.
Sir, I have a question in mind, sir. Can I ask, sir?
Okay, please go ahead.
Sir, in quiz 1, sir, I have not scored well in statistic 2.
Mm-hmm.
I have scored 40 in quiz 1.
Okay.
So, sir, so how will I approach the question in exam, sir? That only I have a question.
Okay. So for that, I have only one answer. You
What,
need
sir?
lots of practice, lots of practice. So you need to solve the same kind of questions without seeing the solution. So what's your approach while you are solving any kind of question? Like you suppose you got stuck in between, so you just saw the solution by the time at the same time, or you are thinking a bit and then approaching or something else like that.
So
What's your
first I see the question, sir. Then, if I stuck, then I take some time, sir, to
okay?
solve.
Correct. So that's a good thing. So what you can do whenever you are solving any kind of question, right? So if you are reading the first statement, try to think the what is the meaning of that first statement and what are the things is given in the first statement. Okay. Let's say in this question itself.
Yes,
So
sir.
X is following gamma distribution, right? So it should be clearly in your mind. Okay, this is the gamma distribution. This should be mean. This should be variance. Okay. The second thing, so whatever the things is given in the first statement, write at the same time. What is the things are given in the second statement, write the things at the. So when you will write the given things in the questions, right? It will give you idea what kind of problem is that particular question. I mean, how to, I mean, how you have to approach that particular problem. Okay, the thing
Yes,
is
sir.
that's the way. And because once you will write, right, so it will be clear what are the things is given to you, what is the what are the things you have to calculate. Okay, so the thing which I can say, just try to solve more questions. Do not see the solution, within a second or within a minute or within 2 minutes. What you can do, try your own, give your best effort. At the end, if you are not, still you are getting incorrect answer. Okay, see the solution of that particular question and try to solve the questions, similar questions, without seeing the solution. Okay, let's say you have solved the this kind of question, let's say this kind of question, right?
Yes, sir.
What should be your next task? You can take normal 0 comma 4 and something x1 square plus x50 square less than 240 or something else. Okay, try to solve something more questions. Okay, so see, you have chat gpt now. Okay, so you can create similar questions for one particular question. Okay, okay, let's say what you can do, let's say you have given prompt to chat gpt. This is the question. Suppose you are able to solve this question, for example. Okay,
Yes,
you
sir.
can give the prompt to chat gpt, create 10 similar questions with the some different value, something like that. Okay, chat gpt will give you in a second, will give you 10 questions with the similar problem. What you can do, try to solve those 10 questions without seeing the solution and without asking the answer with the chat gpt. Are you getting my point?
Yes, sir.
So in today's world, you have lots of opportunity to see the to approach your study part. Okay. The thing is, you should be something should be clear in your mind, and that will come once you will solve more questions. Let's say for CLT itself. So what you have to do, what you have to keep in your mind, whatever the your xi summation of xi divided by n square root of n, what is n into a summation of x, something like that, anything. What you have to do, you have to make it as y or any other random variable. Convert, find the expected value of that y, standard variance of that y, or standard deviation of that random variable y. What is the next task? The After that, the next task is you have to convert in standard form. That's all. Once you convert in standard form, it will you have to do the very basic mathematics. You will get the answer. Okay, is this clear?
Yes, sir.
Okay, all right, correct. So let me see the answers from some big answers. 10 lakhs, 100. Okay, let's see. So if you see the weak law of large number, what weak law of large number says? Okay, this is x bar. What is the mu? Mu is expected value of x bar. Yes or no?
Yes, sir.
And what is the sigma square by n? This is variance of x bar. Basically, what is the task here? You are doing x bar minus expected value of x bar greater than delta less or equal to variance of x bar divided by delta square. Would you agree with me or not?
Yes, sir.
Correct. Now, what is the things given to us? Probability that you can approach like this: absolute difference of xn minus 1 greater than 0.01 less than 0.01. So if you want to convert in this form, so this means this is the x by n. Okay, if you see, like let me approach like this. So if you see, what is the expected value of x here? First of all, x follows gamma n comma 1, right? Then what is the expected value of x will be?
N.
N by 1. What is the expected value of x by n? 1 only.
Yes, sir.
So this is something we have subtracted the expected value of x by n.
Yes.
Right? I will show you this, why this is mean. I will show you. Now, what we have to do, we have to calculate the variance of x by n. Yes or no? So from here, what will be the variance? Variance of x first of all.
N.
N divided by 1 square, that is n. Variance of x by n, this will be 1 upon n square, variance of x. So this will be n by n square, which is 1 by n. So far, so good?
Yes, sir.
Now, so what we have to do, you can see this part, variance of x bar divided by delta square, right? So can I say this part is nothing but this 0.01, this is nothing but variance of x by n divided by, what is the delta? Delta is 0.01 square, yes or no?
Yes, sir.
Yes, sir.
Everyone would will be agree with me?
Sir, just a small query, please. Sir, in this one, you have done variance of x by n as 1 by n square variance of x, right?
Yeah, yeah.
Okay.
You didn't get how? First of all,
Okay. Alpha by beta square, right? Okay.
first of all, are you getting this part or
Yes,
not?
yes, yes,
This is
yes.
okay? Okay.
Yes.
So what we have to do, what is the variance of x? N only?
Okay,
Alpha by
okay.
beta. So this is
Okay.
alpha, this is beta.
Got it. Yeah, n only, correct.
N only. What is the variance of x by n? 1 by n is constant. I can take outside, it will be 1 upon n square, variance of x. What is the variance of x? Which is n. So n upon n square, which is 1 by n.
So no, no, this is okay, sir. This 1 by n square, I was just having a slight query on this 1 by n square. 1 by n
Okay.
square.
So what is variance of a times x if a is constant?
A square into variance. Okay, okay, got it, got it.
Got it?
Got it, got it.
So now, from now here, what will be the case if you see? Can I write basically this? I shouldn't write equal to. It should be something like this. It's not equal to. Can I write this is less than 0.01? Yes or no? So what is the variance of x by n? This is 1 upon n. 0.01 square less than 0.01.
Yes.
Yes or no? So what it will be? Basically, I think it will be n 1 by n, and you can take, it will be less than 0.01 whole cube, right?
Yes, sir.
And what you can do, what you
10
can
power
write down
minus
this,
6.
yeah, 10 raised power
Minus 6.
minus 6, or can I say n is greater than 10 raised power 6,
Greater than 1 million.
right? Is this clear?
Yes.
So this will be your value of n. Is this clear to all of you? Now, if you have doubt why this is x bar, then this is x by n, then you can think like this. I told you earlier. So if I'm saying x follow gamma n comma 1, then can I write x as a, let's assume, I'm just taking the help of these parameters, x1 plus x2 plus x n. This is nothing but okay, so here where each xi will follow gamma 1 comma 1, right?
Yes, sir.
So what is the idea here? If each xi follow gamma 1 by 1, then summation of here xi I is equal to 1 to n. This will follow gamma n comma 1. So now what will be the x by n? This is x by n. I can write x1 plus x2 plus so on plus xn divided by n. Yes or no? And this is nothing but x bar. Okay, so you can use this weak law of large number. Is this clear? Clear to everybody?
Yes.
Sir, sir, X bar was already the mean of the data, no?
Yeah, mean of the data. Yeah, mean of the sample data.
Yeah, but professor had very emphasized this point and this kind
Yes,
of.
this is the random variable, right? It can change. Suppose you have collected sample like this 10010. Okay, what will sample mean? 2 by 5. Okay, suppose you have collected the
Hmm.
sample like this. Now, what is the sample mean? 3 by 5. It will get changed, right? That's why
Yes,
this
sir.
is the
Yes.
random variable. Okay.
Yeah. Yes, sir.
Okay. So value of n should be greater than 10 raised power 6. Now the next question is, I mean the same information is there. You have to find the value of n. Now here you have to use the value of fz. You have to think a bit, a little bit. Basically, here you can use the central limit theorem, right? Are you getting my point? Yes,
Yes.
no, anything. All right.
Yes.
Okay.
Yeah.
So use the
Yes.
central limit theorem. Just see, you have x by n. Okay. Just think x as a summation of xi. Okay. And xi by n. So basically, you have the, okay. Basically, what you can see, just consider x by n as a y. Okay. Then you have to calculate the value of expectation of y, variance of y, and just do the again same procedure. Just convert in standardized form and then do the rest of the things. Okay. So I'm going to give you 3 minutes. Do let me know if you need extra time limit. Okay, do you need extra time limit? Anybody?
Yes, sir.
1 minute?
Yes, sir. One.
Okay, so syllabus is 1 to 4. Sorry, not 1 to 4, 1 to 8 for quiz 2. Okay, major portion will be from 5 to 8.
Not able to do, sir.
Okay, okay, no worries. So anybody else? Do you need extra time limit? Or should we proceed?
Proceed, sir.
Okay, all right. So if you see in this particular question, so it is probability that absolute difference between x by n minus, I mean, it's absolute difference as x by n minus 1, which is greater than 0.01, less than 0.01. All right. So if you see, let me see the responses first from your end. Okay. So if you see here, we consider like this. So probability, uh, so this x following gamma n comma 1, right? So I can let y as a x by n, right? Yes or no? So we calculated in the previous question what is the expected value of y? I mean expected value of x by n. It was 1,
1.
right? And variance of y, that is variance of x by n, was 1 by n,
1 by n.
right?
One by one.
This was the case, right? Now, if you see the central, okay, now what is the given to us? So x by n minus 1 greater than 0.01, this is less than 0.01. Okay. So to apply the central limit theorem, can I read absolute difference y minus 1 greater than 0.01, less than 0.01? So far, so good,
Yes, sir.
right? So you can see from here, what is the next task if you are going to approach the central limit theorem?
We still standardize this.
Right. So to convert into the standard form, what we have to do? Y minus expected value of y, right? Divided by standard deviation of y. You can see expected value of y is already subtracted there. Correct? Then what is the next task? This is the expected value of y, yes or no?
Yes.
Right? No? This is the expected value of y or not?
Yes, yes.
Correct? Then what we have to do? We have to basically divide by standard deviation of y only. Yes or no?
Right, sir.
So the same thing we have to do on right hand side. This will be 0.01. Is this okay to everyone? This point?
Yes, sir.
So what is the standard form? Y minus expected value of y divided by standard deviation of y. All right. So if
Sorry,
you see,
one doubt, sir. One
huh,
doubt, sir.
hmm.
How is y expected like y minus expected value of y is y minus 1, like y is x by n, right?
Huh. What
So
is the
how it is
expected
y
value of
minus
x? In the previous question I have calculated. I am using the information from here. What is the expected value of x here? N only?
n, yeah, n.
What is the expected value of x by n?
Yeah, that also I understood, 1.
So that's the same thing. I just I'm considering x by n as a y. That's all. Are you getting? So what I'm saying, y I'm equating y as a x by n. That's all.
Yeah.
Now it's clear?
Yeah. Yeah, that I got. But
So
how it
the same
okay,
thing,
okay,
right?
okay, okay. I got it. I got it now. Yeah.
Okay.
Okay. Thank you.
So what we have to do to convert in standard form, we have to subtract the expected value of y and divide it by standard deviation of y. But if you see, it's already expected value of y, expected value of y is already subtracted, correct? Then what we have to do, convert in standard form, we have to divide by standard deviation of y, yes or no? What will be the standard deviation of y? 1 upon square root of n.
Correct.
So basically this will be mod of z or not? Yes, no?
Yes, sir.
So if you see from here, so this will be mod of z greater than 0.01 into square root of n, less than 0.01. Would you agree with me?
Yes, sir.
Now, if you have something, okay, can you tell me, can I write this as a z greater than 0.01 square root of n, or z is less than minus 0.01 of square root of n?
Yes, yes.
We can. Now, can I write probability z greater than 0.01 square root of n plus probability z is less than minus 0.01 square root of n? Yes or no?
Yes, sir.
Now, if you see the standard normal curve, suppose this is the mean 0 and suppose this is minus a, any point a. So, if probability, since this is symmetricity, right? Symmetric curve. So, probability z less than minus a, this will be same as probability z greater than a. Would you agree with me?
Yes, sir.
Right? So, can I write this part, probability z less than minus a, where minus a is nothing but 0.01 square root of n. So can I write this part as this part as probability z greater than 0.01 square root of n? Yes or no?
Yes, sir.
Are you getting? So now this will be 2 times of probability g greater than 0.01 square root of n, less than 0.01.
Yes, sir.
Everyone is getting this part? Okay. So this will be
Sir, please
basically
explain last second line.
this one. So
Yes,
by
sir.
the symmetric curve of the normal distribution, can I say probability z less than minus a is equal to probability z greater than a?
Okay, sir. Thank you.
Okay. So from here, it will be probability z greater than 0.01 square root of n less than 0.01 divided by 2. Till this point is clear? Yes or no?
Yes.
So to convert in FZ form, can I write 1 minus FZ of, let's say, not, let me not write FZ directly here. Probability z less than 0.01 square root of n. And what will be this 0.01 divided by 2?
0.005.
0.005, right? Everyone is getting this part, whatever the
Yes,
calculation
sir.
we are doing, right? Okay.
Yes, yes, sir.
So can I write this part as probability z less than 0.01 square root of n? Okay. This is, let me write like this so that it should be clear to all of you. Can I write 1 minus 0.05 less than probability that z is less than 0.01 square root of n? Yes or no?
Yes, sir.
So this will be 0.995 less than fg of 0.01 square root of n. Would you agree with me?
Yes, sir.
What is
Yes, sir.
this 0.995? So if you see fz of 2.58, 0.995,
Yes.
Yes,
correct?
sir.
So can I write fz of 2.58? This is less or equal to fz of 0.01 square root of n or not?
Yes, sir.
Yes, sir.
So from where can I conclude 0.01 square root of n? Okay, can I write 2.58? This is less than 0.01 square root of n or not?
Yes, sir. Both are increasing functions.
Correct. Now, if this is the case, can I write 0.01 square root of n greater than 2.58?
Yes, sir.
So from here, can I write n square root of n is greater than 258?
Yes, sir.
From here, can I write n is greater than 258 square?
Yes, sir.
Right? Whatever the answer will be there, correct? Can you calculate the 258 square? Can you tell, anyone can tell me the value?
6656.
66564.
Okay, this is the answer. Is this clear?
Sir, this is the same question, and we are getting the two different values of n, right?
Correct. So
Different
that,
brackets.
see, weak law of large number gives you the things in probability. That's why it's called weak. This is not a strong law of large number. Okay.
Okay.
So if you search something, we are not going to that much depth. So there is something two kind of law of large number: strong law of large number and weak law of large number. So whenever you use weak law of large number, so suppose something will converge in probability. Okay, so this is in probability. There is, I mean, you are talking about something weak, right? And something called x bar converges to almost sure or something in distribution. So here it's a strong law of large number, something. Okay, so that's the difference. So that's why we are considering different kind of things. Okay, so CLT approximate the things. Okay, in better way when your n is large. Okay, so anyway you will get the value, but that will give you the weak thing. Okay, so approach is clear to all of you.
Yes, sir.
Okay.
Yeah, when you explain it is clear.
Okay. So next problem I would like to do all of you. So this is something we have discussed already. I would expect to do everyone. Okay.
Suppose
Uh,
speed of a vehicle on a particular road are normally distribute की जाती है with mean.
okay. Can you mute? So I have given you 3 minutes. Do let me know if you need extra time. Maybe.
मीन उसका ये होता है स्टैंडर्ड डेविएशन इतना होता है ठीक है हाँ तो अब उसने क्या बोला
Neha. Can you mute yourself? Okay, so I have received only 2 responses. So do you need extra time limit?
So 1 minute, 1 minute. So
1 minute?
Yes, sir.
Oh, all right, no problem.
Sir, just 30 minutes more. I have to just upload the answer. Uh, I was just calculating.
Okay, anybody else? You need extra time limit? Yes, no?
No.
Okay. Okay, then let me solve the question. So question says, suppose the speed of vehicles on a particular road are normally distributed with average, with mean 25 mph and standard deviation is 3. So to find the probability that mean speed x bar of 30 randomly selected vehicles is between 24 and 27. That's a very simple question. Okay. So what you can say, so you can basically define your random variable, let's say x, which denote the speed of vehicles, right? On a particular road. All right. So what is the question says? What is the sample size? 30. And mean is expected value of x is basically mu is 25
Yes.
and
yes.
sigma is given to as a
3.
3.
Mm.
So what you do basically, what you can say, this all x1 to x30, this is IID x, right? Where x follows the normal 25 comma 9. If I'm writing sigma square, right? So what question says, you have to calculate the probability that this x bar mean speed will be between 24 and 27, right? So what you have to do, first of all, you need to calculate the let's say y equal to x bar. So this is x1 plus x2 plus so on x30 divided by 30. Okay. So what is the case if x is following xi following normal mu comma sigma square? What is the distribution of x bar? Normal mu comma sigma square by n. Yes or no?
Yes, yes.
Everyone knows about this, or should I derive?
No, sir.
Okay. Is it clear, right? So if you see uh, what you have to do, so this is 24. What is the next task I have to do? I have to subtract the mean. What is the mean? Mean will be here, x bar will be here, 25 comma 9 by 30. Yes or no?
Correct.
Everyone is getting my point.
Yes.
Yes.
Yes, sir.
Okay, so what is the task we have to do? We have to subtract the mean, right? We have to convert in standard normal form. So we will subtract the mean on both sides. Yes or no? Is this okay?
Yes, sir.
Yes,
Next,
sir.
next task is I have to divide by the standard deviation. What will be the standard deviation? 3 by root 30. Yes or no?
Yes, sir. Yes, sir.
Sigma by root 10, right?
Sigma by root 10, yes.
So this will be x bar minus 25 divided by 3 by square root of 30 less than 27 minus 25 divided by 3 by square root of 30. Correct?
Yes,
And this
yes.
part, if you see this part, red highlighted one, will be the g. Correct? So this will be minus 1 divided by 3 divided by square root of 30 less than g less than 2 divided by 3 divided by square root of 30. Correct? So this will be probability minus square root of 30 divided by 3 less than g less than 2 root 30 divided by 3. Yes or no? So far so good?
Yes, sir. Yes.
What is the next task actually? So this will be, can you calculate this value and tell me the answer? This one.
Oh, minus 1.825.
Minus
825.
1.825 less than g less than this one.
3.65.
3.65. So something you know, probability a less than x less than b. So can I write this is f of
FZ.
b minus f of a?
Yes.
Yes or no?
F
That is something we have learned.
3.65 minus F
Correct.
minus
Correct.
1.85.
So this will be, basically I can write probability z less or equal to 3.65 minus probability z less or equal to minus 1.825. Okay. So at the end it will be fz of 3.65 minus fz of minus 1.825. Okay. So
Yes.
please keep this concept in your mind. This is very, very important for your exam as well. If there is something like this, and you can simply write as a fx of b minus fx of a.
And FX
Okay.
of A.
Where
Sir,
x is continuous. Huh?
sir, can you just go above? Go up once.
Okay.
Sir, slide, yeah. Sir, in this one, just one more line up.
Hmm.
Yeah. So basically, sir, in this one, we can also do like P of 24 less than X bar less than 27, right? So in this one, if we open like X bar as X1 plus X2 plus till X30 by 30, and we define X1 summation of X1 till X30 as Y, then we will already get like in
Same thing. Anyway, then you will get, see, again you will get the same thing. If you are defining y
right.
as a x1 plus x30, then you will, what will be the mean? Here it will be 30 into 25.
Correct,
To
correct.
calculate the x bar, you have to again divide by 30. Again you will get the 25. So at
Right.
the end you are going to get the same
Same
answer.
result. Okay.
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 Understood? Fine.
Both ways are correct, right, sir?
Both ways are, that's not a problem. The only thing you shouldn't make the calculation mistake. Otherwise, fine.
Excuse me, sir.
First answer is correct, yeah.
Excuse me, sir.
Yes, first is correct. Yes.
Sir, whenever we have to find the x between in two digits, then we have to follow this step.
Yeah, same thing. The
Okay,
key
sir.
thing what you have to do, whatever the random variable is there, right? You have to convert into standard normal form. That's all. Whether it's in between or x bar is greater than 27 or x bar is less than 25, anything, you have to convert this part into z. And for that,
Z.
what you have to do, you have to calculate the expected value of that part, variance of that part, and then calculate the standard deviation of that part, and just subtract the expected value and divide by the standard deviation. Okay. So you can see this in the slide itself, there are different kind of questions related to central limit theorem, right? Something is in between, something is greater, something is less, right? You can see. So this was in between, we did like this, and this was greater than, we did the same thing. And let's say this is okay, this was the weak law of large number. You can say this is greater than, you can, okay, next part, this, and again you can see this is greater than. So we have done some different kind of questions. Okay, you can think of it. Okay, all right. Yeah, go ahead.
The probability that we have calculated are actual probabilities or just approximate ones?
Yeah, this is the approximate value. That's not an exact value.
Okay, sir.
Sir, you'll be uploading the notes, this notes today, right?
Which one? This PDF or you want mine?
So this PDF as well as maybe the one also, both here.
Okay, so mine PDF, which whatever I'm writing here, you can find under live session notes, and that solve with this PDF you can find under supplementary content. Okay, peer depth slide something. Okay.
Okay.
Yeah. So the next question is, what is the fourth moment of the normal 0,9 distribution? Okay, that is something you to try. I'm going to give you 3 minutes. Just try and let me know.
Fourth moment of the normal. कुछ नहीं करना है.
Okay, so do you need extra time limit? Anybody? Or is it fine to proceed?
Proceed.
243, 40.5. Okay. Okay, so what is the MGF first of all? Anybody, any thought? How will you define the moment generating function?
So for normal distribution, it is given by e raised to lambda square sigma square by 2.
It's
Let me
just the
define. Suppose
expectation of e to the power
you
lambda x.
correct. So if you have a x, let's say x is a random variable, okay, then the MGF of x, okay, the MGF stands for moment generating function of x, and nothing but it's a function from basically R to R, and which is I will say which is defined as nothing but, if I'm writing mx lambda, this is nothing but expected value of e raised power lambda times of x. So this is mx moment generative function is defined for any random variable. So from moment generating, if you see the word, it generates the moment. Okay, it is a function which generates the moment. So moments and all, basically this MGF moments and all is helpful whenever okay, this is not in our course. Basic, I mean, it's a very basic thing. This is called something called kurtosis, skewness, and all. So kurtosis and all, the skewness. How will you find the whether your distribution is skewed or not? So the skewness is defined something mu1 dash square divided by mu2 dash square, something like that. Okay, and what kurtosis tells us with peakness of your curve. Okay, of the curve of any distribution. Why I'm saying like this? So this with the help of moments nothing but, so if you will say expected value of x, this is called the first moment. Okay, expected value of x square is called second moment. Expected value of x cube will be the third moment. Expected value of x4 will be the fourth moment. Okay, the thing is, this moments is going to help you to find this kurtosis, skewness. This is one of the importance of this moment generative function. Others is, if you have been given mgf of a random variable, right, then you can easily see mgf is uniquely defined. So what do you mean by uniquely defined? If you have been given mgf of any random variable, you can identify the distribution of random variable. Okay, so how to proceed? So mx lambda is nothing but expected value of e raised power lambda x, right? How will you define expected value of x if you have discrete random variable? Summation of x into probability of x equal to x, right? If x is continuous, it will be x fx dx. Yes or no?
Yes.
Okay, so condition is this should be exist. So can I write here, if x is, let's say I'm writing x as a drv, it stands for discrete random variable, then this will be summation of e raised power lambda x into probability that x equal to x. Yes or no?
sir.
If x is CRV, means continuous random variable, then it will be, you have to integrate e raised power lambda x into fx dx, right? That is something you can proceed. Yes or no? Okay, let's see. For the normal distribution, it should be in your mind, right? If like as sir has mentioned, if I'm saying x follows normal with mean 0 and variance sigma square, then mgf of this normal distribution is nothing but e raised power lambda square sigma square divided by 2. That is something it should be in your mind. Okay, but the thing is, okay, now let's come back to our question. So our question says we have been given this we have to calculate the fourth moment of normal 0, 9. So that means we have to calculate the expected value of 4. Yes or no? So if you see, mx lambda will be expected value of e raised power lambda times of x, right? If you expand this, can I get 1 plus lambda times of x plus lambda square x square divided by 2 factorial? Yes or no? Plus lambda cube x cube divided by 3 factorial plus lambda 4 x raised power 4 divided by 4 factorial. Okay, so something, this is the expansion of e raised power x. So 1 plus x square divided by 2 factorial plus x cube divided by 3 factorial plus so on. So instead of x, we have lambda x. Is this clear to all of you?
Yes, sir.
Now, if
Yes.
you take expectation inside the bracket, it will be 1 plus lambda times expectation of x. Yes or no? Plus lambda square divided by 2 factorial into expectation of x square plus lambda cube divided by 3 factorial expectation of x cube plus lambda raised power 4 divided by 4 factorial expectation of x raised power 4 plus so on. Yes or no?
Yes, sir.
So what is the, if you see the fourth moment, okay, what is the fourth moment which is expected value of x raised power 4? What is this? This is coefficient of lambda raised power 4 divided by 4 factorial. Would you agree with me?
Yes,
Yes,
sir.
sir.
So in general, kth moment you can calculate as expected value of x raised power k as a coefficient of lambda raised power k divided by k factorial. Yes or no? So what we have to do, we have to find the coefficient of lambda raised power 4 divided by 4 factor, right? The thing is, we have been given normal 0, 9. Okay, so can I say this is normal 0, 3 square or whatever? So mx lambda for normal distribution is e raised power lambda square sigma square by 2. So sigma square is 3 square divided by 2. Yes or no?
Yes, sir.
Now, if you will expand this, so it will be 1 plus lambda square 3 square divided by 2. Basically, what is the expansion of e raised power x? E raised power x is nothing but 1 plus x square divided by 2 factorial plus x cube divided by 3 factorial and so on, right? This is x. What will be x square? So this will be lambda raised power 4. Okay. 3 raised power 4 divided by 4 into divided by 2 factorial. Yes or no?
Yes, sir.
So everyone is getting this part?
Yes.
Yes, sir.
Now to what we have to do, we have to find the coefficient of lambda raised power 4 divided by 4 factorial. So if you
Sir,
see,
explain this part.
so
Explain this part, sir.
we have to do x square divided by 2 factorial, right? What is the
Okay.
x here? This is e raised power x. This is whole x, right? If you will do square of this, lambda raised power 4, 3 raised power 4, 2 square, that is 4, divided by 2 factorial, divided by 2 factorial. Is this clear now?
Yes, sir.
Now to convert into the 4 factorial, what we have to do? Can I do 3 raised power 4 divide by, basically can I multiply with 3 and divide by 3?
Yes, sir.
Yes or no? Just to convert this part into 4 factorial. Now if you see, the denominator is nothing but 4 factorial, yes or no? So 3 raised power 4, which will be
81.
81 into 3, which is 243. 243 lambda raised power 4 divided by 4 factorial, yes or no? So what is the coefficient of, sorry?
243.
So this will be 243. So 243 is the answer. Yes?
One doubt. Is there any third moment for normal distribution?
Is there any?
Third moment, first moment.
Yes, yes. It depends, right? It can vary, right? So if you
expansion, we can see lambda square, lambda power 4, only even numbers.
See, if you will do normal 0, 1, then just try it out, right? It depends on the parameters.
Okay, sir.
Okay. So is the idea clear about this? So 243 is the answer actually, you can see. Okay. Is the funda clear? Whatever the things, yeah, it is 0 for odd powers, correct. So is this clear idea? So we have the very interesting slide, which is something, thank you. And I'm hoping you got the concepts, whatever the things we have learned so far. Okay. So I think you will be having math session, right? From 8 p.m.
Yes, sir.
Yes, sir.
So I'm assuming, I'm hoping everyone got the concept related to central limit theorem. One idea I'd like to mention, which is in which is in one of the activity, I would like to ask to all of you, how will you approach for this question? Because this is something, in this kind of question, most of the people face difficulty. So if you see the last question, okay, can you tell me how will you approach? This is the last question I will discuss, and then I will wind up the session. In this question, if you see, the number of accidents in a certain city is modeled by Poisson random variable with an average rate of 9 accidents per day. Okay. Then suppose, okay, what is the given to us?
Mean and variance.
So let's say X, I'm defining X as a number of accidents, okay, in a certain city. Okay. Then X follows Poisson distribution with average rate 9. So that means lambda will be 9. Right?
Yes,
Mean is 9 and variance is also 9.
Correct.
Suppose the number of accidents on different days are independent, use the central limit theorem to find the probability that there will be more than 3,300 accidents in a certain year. This is the twist part here. Why this is the twist part? Because, and just assume there are 365 days in a year. So what you have to do basically, if you see here, okay, so how will you define? There will be your x1 to
x365.
Correct. Now let's define y as a total number of accidents throughout the year? Can I
Yes,
say?
sir.
Okay. So what will be? This will be probability that y greater than 3300. This is something we have to calculate,
Yes, sir.
right? What will be the mean of this expected value of y? 9 into
65
365,
into
65.
9.
Yes.
whatever the values. What is the variance of y? 9 into 365?
Correct. Same.
Same,
Poison.
right? Right? And standard, okay, so what we have to do? Just usual approach. So it will be probability that y minus expected value of y divided by standard deviation of y. So this will be greater than 3300 minus, can you calculate this one?
3285.
3285. Then divide by square root of 3285. Okay. Then if you see, this will be g greater than whatever this value, right? This is 15. And divide by square root of this. I'm not going to calculate the further. This is just idea. Then next what you can do, 1 minus probability z is less or equal to 15 divided by square root of 3285, and then you can calculate the further values, right? This will be 1 minus fz of whatever the values of. What I'm trying to say here, sometimes it is, there is a twist where you have to think about a year, right? Sometimes like sometimes people take 9 as a mean and variance in this case also. That's why I mentioned this particular problem. Okay, all right.
Yes, sir.
Okay, then I hope you got the concept related to this central limit theorem. Okay, uh, thank you everyone.
Thank you, sir.
Thank you.
Thank you, sir.
Okay, we'll meet
Thank you, sir.
tomorrow in for the revision session of week
So,
7. Okay,
find out from the mock of week.
you have to doubt from mock. Don't
Yes.
worry, there will be a session for special session for mock, okay, which is on Thursday. Don't worry, we will discuss there. Okay, till then, what you can do, just try on your own. Okay,
Okay, the deadline has passed. So
deadline
I
is passed.
so
So mock
Sir,
for quiz 2. Are you
there are
talking?
two mock. One is weekly mock of week 5 and 6. I have doubt from that one.
Okay, what is your doubt?
Sir, can I just post it on the chat?
Okay, you can post on the chat. That's not a problem. Or else, for the safe side, you can tag me on Discourse. I will write the solution there. Or will that be all right?
Yes,
Which
sir.
question you are talking referring?
Sir, I guess it's the question number 8.
Question number
So we
8.
can leave the session, right?
Yeah, yeah. It's we can you can leave. That's not a problem. We are done. Okay, so this is something you have to apply the Bayes theorem, right? Of from the week 5. Yeah. What is your doubt?
No, sir. The doubt is in. Sir, it's in question number 6. Sir, I have a doubt that why first option is incorrect.
Question number 6.
Yes, sir.
See, if you see what is the fxy, if you whenever your region D is given to you, right? So like it depends. So fxy is nothing but 1 upon modulus of D. I mean 1 upon basically 1 upon area of D. Okay. So you have to find the area of D first and 1 upon that. So that is 1 by 5. Okay. How you are calculating? You are calculating for separate, right? So you can find the area. What is the area of first square?
Sir, it's 1.
1, right? And what is
Yes.
the area of the second square box?
It's 4.
4. So 1 plus 4.
Okay, sir.
Got it?
Yes, sir.
Okay. Okay. Okay then. Thanks. Thanks. Bye.
Thank you, sir.
Thank you.